Hello, good evening. This is the second video of our topic, singly reinforced concrete section, WSD method. Last video, we discussed the bending stress, shearing stress, bonding stress, stirrups, and the detail of the section. So this video we have WSD problem for the singly reinforced concrete section. WSD means working stress design. WSD is an acronym for the working stress design. So we have a problem here. The problem, a reinforced concrete beam is supported and loaded as shown in figure. So this is the figure. It carries a uniform load of 1,530 kg per meter. Excludes beam dead load. Meaning, this beam is carrying a load of 1,530 kg per meter. Exclude the weight of the building, the weight of the column is not included with this weight. Design a singly section. Design a singly reinforced section using F'(C) 21.0 megapascal, FS 140 megapascal. Use WSD method. So this is the figure. This is the beam and it is supported here and this here. Point A, point B. The distance of this is 9 meters and the overhang is 3 meters. The first thing to do here is to solve the reactions in the support A and support B. How do we solve that? By means of moment. Summation of moment at this point. Summation of moment at B equals 0, assuming the counterclockwise moment is positive. This is the B. Summation of moment at B here. This is a uniformly distributed load. We have to make this concentrated load. Here, concentrated load. To convert this into concentrated load, we have to multiply the W with the length of the span. 12 times W, this is 12 times W, this is concentrated, times the lever arm here. This distance is 6 meters. 6 meters. And this is the action of the reaction B. So here is 6 minus 3 equals 3. That's why we have this 12W times 3. This is the 3. So that is this concentrated load. This is 12W. Okay? And then this is positive because this is counterclockwise from here. This one, counterclockwise. So that is positive according to our assumption. And the reaction here in point B is clockwise direction, is 9 times A. Clockwise direction is negative, so equals 0. So 12 times 3 is 36W, and we will transfer this one to the other side, 9A. So this is now the equation. So 36W divided by 9 is 4W. So therefore, the reaction here is 4W, this one, 4W. And the reaction here in the support B, we solve it, summation of vertical force equals 0, assuming the force going up is positive. So that is it. This is going up. The A, that is 4W, is going up, so positive. 4W, so positive. And the concentrated load of 12W is negative. That's why this one, 12 here is minus 12W, minus because going down, that is negative. And the B is going up is positive, so equals 0. Okay, combining this, positive W, negative 12W become negative 8W plus B equals 0. Transferring the negative 8W to the other side of the equation, negative become positive. So B now, here, the reaction is 8W. Okay. After solving the reactions, we have to draw the shear diagram of the load. This A is 4W going up, so this is the magnitude. Okay, this 4W, and the beam from here to here is 9W. That is negative. 9W minus 4, because we start here. The line will start here up to here. So 9 minus 4 is 5. Since this is negative, so negative sign. Okay. The next is the reaction B, that is 8W. 8W minus 5W is 3W. That's why this point is 3. This here, 3W. And next is the portion of the beam from here up to here is 3. The overhang is 3. 3 times W is 3 times W, negative. So from here up to here. So this is close, meaning our computation is correct. Okay. After the drawing of the shear, we have to compute, solve, determine the distance of this. Okay. To solve the distance of this and this, assume that this is angle P. Angle P. We have to make a parallel line of this. In the AutoCAD term, we will make an offset line of this, parallel of this line. So, we will make this parallel. Parallel line is never meet. This line, since this is a parallel, so never meet. So this is parallel line. And the angle here is the same with the angle of that. Angle P. Okay? And this is 5. Is 5W. 5W. There, in other words, here, up to here, is 9W. 9W. The same with this. This is 9W. 9W. Now, to solve the value of this, we have to solve the value of the angle P. From the spherical trigonometry, tangent. Tangent P is equals to opposite. Where is the opposite? Here. This is the angle. The opposite is here. Opposite divided by the adjacent. This is the adjacent. 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 And this is 9. Equal to 9 over 9. In other words, this is 9 over 9 is 1. So, we have now the tangent P is equals 1. And in your scientific calculator, when you press the 1, then pressing the tangent, pressing the inverse tangent, it will give you the value. It will give you the value of P is 45 degrees. 45 degrees. Try to press 1, then inverse tangent. Will give you this, 45 degrees. Meaning, this angle is 45 degrees. 45 degrees. That is 45 degrees. Now, when 45 degrees, if this is, when we 45 degrees, meaning this distance is equal to this distance. Like this. Become 1. So, therefore, if this is 4, meaning this is 4 also. And this is 5. This is 9. So 4, then this is 5 up to here. Okay, that is how to solve the value of this distance. Okay. After that, that's the time to draw the moment diagram. This diagram, this is positive area. The area of this triangle is 1/2 times the base times the height. Meaning, 4 times 4 is 16, divided by 2 is 8. Meaning, this is 8W. Here, 8W. That is the positive moment. Okay, then, this one is negative area. The same procedure with this. 5 times 5, this one. 5 times 5 is 25. Divided by 2 is 12.5. 12.5 minus 8W. We draw the line here. Up to here. So the remaining 12 minus 8 is 4.5W. This is negative. Okay. After that, this positive area. Positive area. 3 times 3, 9. Divided by 2 is 4.5. And this is 5. So, starting here, 4.5 positive. So, this is plus, becomes 0. So, meaning, our data here are correct. By the way, the area is 1BH. That is the area. BH, 4 times 4 equals 16, divided by 2 equals 8. 5 times 5, 25, divided by 2, 12.5. Then 12.5 minus 8, 4.5. And this also area, 3 times 3 is 9, divided by 2 is 0.45. 4.5 here. That is correct. Meaning our data is correct. Okay, we will start the solution of the problem or the sample problem for the singly reinforced WSD method. This is the solution. We have to compute first the acting loads. Assuming that the dead load, we have to assume the dead load because there is the 1,530 kilogram per meter. The weight of the beam is not included. So we have to assuming the dead load is 34% of the live load. Live load here is this one. The live load is this one. Then 34% is 0.34 times the live load, this one. So, computing this, we have 520.20 kilogram per meter. Okay, per meter. So, the W, the total load is equals to dead load and the live load. Dead load is 520.20, this one. And the live load is 1530, this one, 1530. Okay. When you combine this, it will give us when you combine this, the result will give us kilogram per meter. And we have to convert it into kilonewton. How do we convert? 1 kilogram is 9.81 Newton. So we have to multiply this one. The result of this multiplied by 9.81 Newton. Then, since we need kilo Newton, so divided by 1,000. Divided by 1,000 to obtain the kilonewton per meter. So that's why we have this. Meaning this is times 9.81. 81 divided by 1,000 to obtain this one. Yes. Whatever the sum of this one, multiplied by 9.81, then divided by 1,000. So will give us 20.1125 kilonewton per meter. So, say W is equal to 20.0 kilonewton meter. So that is now the value of the W. Okay, that is the value of the W. Okay. Compute. Then, after that, compute the design stress. Design stress. Maximum moment. Maximum shear is 5W. Maximum shear from the shear diagram. That is 5W. 5 times 20. This is the 20. Will give us 100 kilonewton. 100 kilonewton. That is the maximum shear. And the positive moment from the moment diagram, 8W, which is 8 times 20, will give us 160.0 kilonewton meter. That is the drawing of the this is the 4.5 W. This is 8W. Okay, that is this one. This is positive moment. This moment positive. Let us say yan. Yeah. And 8 times 20. W is 20. Will give us this one. And the negative moment is this one. 4.5 times 20. That's why we have this. Then after that, we compute the design factors. K. This is K. Design factor equals 1/1 plus Fs divided by the N and Fc. This is the specified tensile strength of the steel bar, and this is modular ratio, and this is the compressive strength of the concrete. And the compressive strength of the concrete is 45% of the Fc prime, which is 21.0. So will give us 9.45 megapascal. Okay. Next is the modular ratio. This is the modulus of elasticity of the steel, modulus of elasticity of the concrete. This is the equivalent 200 times 10 to the third for the steel, and 4700 times the square root of the F prime C. So will give us 9.286. Say 9. We will adapt 9. This one. We will adapt 9. This is greater than the 6, which is the minimum value of the modular ratio. This is okay. 9 greater than 6. After that, we compute the K, value of the K, design factor. 1/1 plus this 945 will give us 0.3780. Okay, that is the K factor. and the z is equal to 1 minus k over 3. Substituting this here and divide with 3 will give us 0.8740. That is the J design factor. And the R is 1/2 FC JK. Substituting all the values that we have will give us R is 1.5610 megapascal. Okay. Number 3 is stress of beam. Okay. Stress of beam. I do not know if you remember. The stress of the beam is M is equal to RBD squared. Actually, this equation is from here. Okay, from here. But since we need this one, so we transfer this into this equation. So M now is 160 times 10 to the 6 power, or 10 to the 6, then divided by the 1.56, which is, that is the R, value of the R, then will give us 102.50 times 10 to the 6 cubic millimeter. Cubic millimeter. Okay. After we computed the value of BD squared, this one, after that, then next we have to assume the ratio of the base to the effective depth of the section. Now, the most economical section is, the ratio is range from 1.50 to 2.50. That is the most economical ratio between the base of the section. This one, this is the base, and this is the D. So the most economical is 1.5 to 2.5. That is the ratio and the economical ratio. So let DB is equal to 1.8, meaning this is somewhat in between of this range, 1.5 to 2.5. This 1.8 is somewhat between of this. Okay, so we need the base. We solve the base. So base, when we transfer the base here and transferring also this into here, is become like this. When you transfer that into other side, become D is become 1.80 B. Then B, when you transfer that, we will transfer this in the left side. D now is divided by, this is multiplication times. So when you transfer the multiplication here, become division, 1.8. So this is now the value of B, this one, D over 180. Okay. from the equation, b d squared we will substitute the value, value of b. When you substitute that, meaning the b is d over, become like this, d over 1.8 times d to the third. No, to the square, like that. Therefore, we have to d times d squared equals d 3, and the 102.5 times 10 to the 6 multiplied by 1.80, so this one, d3 now, okay, d3 now is become this one. And when we going to compute this, when we're going to compute it, whatever the result, we will take the cube root of the d. Cube root, when you see like this, cube root is 3. So cube root of this, cube root of 1.80 times 102.5, 10 to the negative 6. That is, when you this one, when you're going to perform this, if you want to compute that in your calculator, take the value of this and press the cube root in the calculator, scientific calculator, and the cube root will come out 569.290 millimeter. So say d is equals 570 millimeter. This is now our d. This one, 570.